Hello students, in this video we will discuss internal energy, heat and work, and first law of thermodynamics. In thermodynamics or thermochemistry for B.Sc part 1 chemistry courses, these topics are also included in 11th chemistry syllabus book 1. This is lecture number 1 of thermochemistry और thermodynamics. इस वीडियो में हम लोग B.Sc पार्ट 1 केमिस्ट्री कोर्सेज के लिए थर्मोकेमिस्ट्री और थर्मोडायनामिक्स में इंटरनल एनर्जी, हीट एंड वर्क एंड ऑल्सो फर्स्ट लॉ ऑफ थर्मोडायनामिक्स, वेरी वेरी इंपॉर्टेंट टॉपिक्स को डिस्कस करेंगे, जो कि क्लास 11 केमिस्ट्री बुक 1 के सिलेबस में चैप्टर थर्मोडायनामिक्स में इंक्लूडेड. First of all, internal energy of a system. Total energy of a system, which may be either mechanical energy or chemical energy or electrical energy or any type of energy. Hence, total energy of a system is called internal energy of that system. So, internal energy of a system is defined as total energy of a system is called internal energy. Right now, total energy of a system is called internal energy. किसी सिस्टम की टोटल एनर्जी को, किसी भी सिस्टम में एनर्जी होती है, प्रेजेंट होती है, तो सिस्टम की टोटल एनर्जी को इंटरनल एनर्जी कहा जाता है, जो कि किसी भी फॉर्म में हो सकता है. केमिकल एनर्जी हो सकता है, मैकेनिकल एनर्जी हो सकता है, इलेक्ट्रिकल एनर्जी हो सकता है, या किसी अदर फॉर्म का एनर्जी हो सकता है. तो उस सिस्टम की टोटल एनर्जी को उस सिस्टम की इंटरनल एनर्जी कहा जाता है. एंड इट इज डिनोटेड बाय द सिंबल, इंटरनल एनर्जी इज डिनोटेड बाय द सिंबल कैपिटल यू और कैपिटल ई. इंटरनल सिस्टम का इंटरनल एनर्जी को कैपिटल यू और कैपिटल ई दोनों सिंबल से हम रिप्रेजेंट कर सकते हैं, कैपिटल यू से भी और कैपिटल ई से भी. लेकिन यूजुअली कैपिटल यू सिंबल से सिस्टम का इंटरनल एनर्जी को रिप्रेजेंट किया जाता है. सो टोटल एनर्जी ऑफ ए सिस्टम इज कॉल्ड इंटरनल एनर्जी एंड इट इज डिनोटेड बाय द सिंबल कैपिटल यू. दैट इज इंटरनल एनर्जी यू इज इक्वल टू टोटल एनर्जी ऑफ ए system. Internal energy is an extensive property, that is thermodynamical property of a system. Internal energy किसी सिस्टम का, सब्सटेंस का एक्सटेंसिव thermodynamical property है. and internal energy is a state function. इंटरनल एनर्जी एक स्टेट फंक्शन है, जो कि सिस्टम के इनिशियल स्टेट एंड फाइनल स्टेट पर डिपेंड करता है. किस पाथ को फॉलो करेगा सिस्टम फॉर चेंज इन स्टेट, उस पर डिपेंड इंटरनल एनर्जी नहीं करता है. सिस्टम का इनिशियल स्टेट, ओनली सिस्टम का इनिशियल स्टेट एंड फाइनल स्टेट पर डिपेंड करता है. देयरफॉर इंटरनल एनर्जी इज ए स्टेट फंक्शन. इंटरनल एनर्जी डिपेंड्स ऑन द नेचर ऑफ द सब्सटेंस एंड ऑल्सो ऑन द कंडीशंस लाइक प्रेशर एंड टेम्परेचर. It also depends on the volume of the substance. So write down internal energy is an extensive property, that is thermodynamical property of a system or substance, which is a state function which depends on the initial and final state of the system. Now we have to discuss heat. Internal energy of a system, heat, which is denoted by the symbol Q, a small q or capital Q. Here we have used the symbol a small q for heat. Internal energy of a system may be changed. Internal energy of a system may be changed due to transfer of energy, heat energy from system and its surroundings. Therefore, the transfer of energy from the system or between the system and its surroundings due to temperature difference is called heat. So that the internal energy of the system may be changed. तो हीट एनर्जी को और हीट को हम डिफाइन कर सकते हैं एनर्जी का ट्रांसफर सिस्टम एंड सराउंडिंग के बीच टेम्परेचर डिफरेंस के कारण, टेम्परेचर डिफरेंस सिस्टम एंड सराउंडिंग्स के बीच में टेम्परेचर डिफरेंस के कारण एनर्जी का ट्रांसफर सिस्टम एंड सराउंडिंग के बीच होता है, सिस्टम से सराउंडिंग में या सराउंडिंग से सिस्टम में, उस एनर्जी को, दैट इज ट्रांसफर ऑफ एनर्जी ड्यू टू टेम्परेचर डिफरेंस के कारण सिस्टम एंड सराउंडिंग के बीच जितने एनर्जी का ट्रांसफर होता है उसे हीट एनर्जी कहा जाता है. एंड इट इज डिनोटेड बाय द सिंबल, हीट एनर्जी इज डिनोटेड बाय द सिंबल अ स्मॉल q और कैपिटल Q. Heat energy, a small q, say a small q, is taken as positive when heat is transferred, that is energy is transferred from the surroundings into the system. In that case, heat energy q, say q, may be taken as positive, that is plus q. जब एनर्जी का ट्रांसफर, हीट एनर्जी का ट्रांसफर सराउंडिंग से सिस्टम में होता है तो हीट एनर्जी को पॉजिटिव माना जाता है. इन दैट केस हीट एनर्जी Q इज टेकन एज पॉजिटिव. ऑन द अदर हैंड, इफ द हीट एनर्जी इज ट्रांसफर्ड फ्रॉम द सिस्टम टू इट्स सराउंडिंग्स, देन हीट एनर्जी इज टेकन एज नेगेटिव. So Q is positive when heat is added to the system from the surrounding, and it is negative when heat is rejected to the surroundings. So first of all, write down the definition of heat, which I have already stated. The exchange or transfer of energy between a system and its surroundings ड्यू टू, इसके कारण टेम्परेचर डिफरेंस के कारण, ड्यू टू टेम्परेचर डिफरेंस एनर्जी का ट्रांसफर क्यों होगा? ड्यू टू सिस्टम से सराउंडिंग के बीच में एनर्जी का ट्रांसफर क्यों होगा, कैसे होगा? तो टेम्परेचर डिफरेंस के कारण होगा. सिस्टम एंड सराउंडिंग्स का टेम्परेचर डिफरेंस के कारण एनर्जी का ट्रांसफर सिस्टम एंड सराउंडिंग के बीच में होता है, और उस एक्सचेंज ऑफ एनर्जी और ट्रांसफर ऑफ एनर्जी को क्या कहा जाता है? हीट एनर्जी कहा जाता है. So the exchange or transfer of energy between the system and its surroundings, due to temperature difference between them, that is between the temperature difference between the system and surrounding. Temperature difference between them is called heat energy. Heat energy, it is denoted by the symbol a small q or capital Q. Q is taken as positive. Q is taken as positive if Q is equal to plus Q when heat is added to the system from the surrounding. When Q is taken as heat energy is taken as positive when heat is supplied to the system from the surroundings, from its surroundings. Heat is supplied, that is heat energy is supplied to the system, and heat energy Q is taken as negative when it is given out of the system to the surrounding. That is, if heat is rejected to the surrounding from the system, heat energy is taken as negative. So Q is equal to minus Q when heat is supplied to the system or heat is transferred to the system. तो जब सिस्टम से सराउंडिंग से सिस्टम में हीट का ट्रांसफर होगा तो हीट एनर्जी को पॉजिटिव माना जाता है, तो Q इक्वल टू प्लस Q होगा. एंड जब सिस्टम से सराउंडिंग में हीट जाएगा, हीट का ट्रांसफर सिस्टम से सराउंडिंग में होगा तो हीट एनर्जी नेगेटिव होगा, दैट इज Q इक्वल टू स्मॉल q इक्वल टू माइनस Q इन दैट केस. नाउ वी हैव टू डिस्कस वर्क. Internal energy of a system can also be changed by the work done on the system or work done by the system. किसी सिस्टम का इंटरनल एनर्जी, जैसा कि इसके पहले केस में हमने हीट एनर्जी के केस में देखा कि सिस्टम का इंटरनल एनर्जी को सिस्टम का इंटरनल एनर्जी में चेंज हो सकता है हीट एनर्जी के ट्रांसफर से. उसी ढंग से इंटरनल एनर्जी का सिस्टम एक अदर वे में भी एक अदर वे में मतलब एक अन्य ढंग से भी हो सकता है, जो कि वर्क डन ऑन द सिस्टम और वर्क डन बाय द सिस्टम. इफ देयर इज ए वर्क डन on the system, then work done is taken as positive, and if work done by the system, then work done is taken as negative. So if for work done on the system, there will be change in internal energy of the system. Also for work done on the system, for change in internal energy of the system, for work done on the system, for work done on the system, it is taken as positive. W is equal to positive plus W. And for work done by the system, it is taken as work done is taken as negative. W is equal to minus W, that is negative. So internal energy of a system can also be changed by the work done on the system and work done by the system. There may be work done by an ideal gas during isothermal process, as well as work done by the ideal gas during the adiabatic process. We will derive expressions for work done by the system during adiabatic process and during the isothermal process separately in the next video of the thermodynamics which we have already discussed in class 11 physics chapter thermodynamics. Now in last we have to discuss first law of thermodynamics, very important principle, which is the alternative statement of the first law of which is the alternative statement of the law of conservation of energy. So write down first law of thermodynamics. Total energy of a system and its surroundings, that is total energy of an isolated system, remains constant, and it is known as the first law of thermodynamics, which is the another statement of the law of conservation of energy, which is energy can neither be created nor be destroyed. Energy may be exchanged from energy may be transformed from one form of energy into another form of energy, but energy can neither be created nor be destroyed, which is known as the law of conservation of energy. And first law of thermodynamics is also the alternative statement of the law of conservation of energy, and it states that total energy of an isolated system remains constant, that is energy can neither be created nor be destroyed. Write down the first law of thermodynamics. Total energy of an isolated system, or total energy of a system and its surrounding, remains constant. Total energy of an isolated system remains constant. That is, energy can neither be created nor be destroyed. And it can also be expressed as in form of change in entropy, that is delta U, which is change in entropy of the system, that is delta U is equal to UF change in internal energy of the system. Capital U is the symbol of internal energy, not of entropy. I am very sorry. So change in internal energy of the system, that is delta U is equal to UF, that is final internal energy of the system, minus UI, internal energy of the system. This difference, UF final internal energy minus initial internal energy. UF is the final internal energy of the system. UI is the initial internal energy of the system. This difference is delta U, and it is equal to Q, amount of heat added to the system, plus W, work done on the system. This is the mathematical form of first law of thermodynamics. In terms of change in entropy, delta U is equal to UF minus UI, that is final internal energy, minus initial internal energy, UI, and delta U is the change in internal energy of the system, is equal to heat added to the system, a small q, plus work done on the system. If heat is added to a system, its internal energy increases. If there is work done on the system, then internal energy, that is final internal energy, in that case may be expressed as UF final internal energy may be expressed as, if UI is the initial internal energy of the system, that is UI, plus if Q is the heat added to the system, अगर बाहर से सिस्टम में Q अमाउंट ऑफ हीट ऐड कर दिया जाए और UI इनिशियल इंटरनल एनर्जी सिस्टम का है, तो जब हीट उसमें ऐड कर देंगे सिस्टम में, तो सिस्टम का इंटरनल एनर्जी इंक्रीज कर जाएगा। तो अब सिस्टम का इंटरनल एनर्जी इंक्रीज होकर के UI प्लस Q हो जाएगा। एंड इफ फर्दर if there is work done on the system, so W is if there is work done on the if there is work done on the system, then work done is taken as positive. I have stated it in this video. So if work done on the system, then total internal energy of the system UF is equals to UI, initial internal energy, plus amount of heat added to the system, plus work done on the system. And this UF minus UI, अगर UI को लेफ्ट हैंड साइड में लाया जाए तो UF minus UI, that is final internal energy minus initial internal energy, that is delta U, change in internal energy of the system. It is delta U, and it is equal to, in RHS it is equal to Q plus W. A small q, heat added to the system, and W is the work done on the system. So it is, that is change in internal energy delta U बराबर is equal to UF minus UI is equal to amount of heat added to the system, say it is a small q, plus work done by the system, work done on the system, which is W. If there is work done on the system, then work done is taken as positive, so it is Q plus W. And this is the mathematical form of first law of thermodynamics. Write down, this is the mathematical form of thermodynamics. If there is work done by the system, in case work done by the system, we know that if there is work done by the system, then work done is taken to be negative. So if there is work done here, W is the work done on the system, so it is positive, taken as positive. But if there is work done by the system, then first law of thermodynamics in form of change in entropy may be expressed as delta Q is equal to Q minus W, in case if there is work done by the system. Suppose it is equation number 2, and equation 1, which is already change in internal energy delta U, change in internal energy of the system, delta U is equal to final internal energy UF minus initial internal energy UI. So change in internal energy of the system delta U बराबर UF minus UI बराबर Q, that is amount of heat added to the system plus amount of heat added to the system plus amount of heat added to the system, which is denoted by the symbol Q, and work done on the system, which is W. So it is Q plus W is equal to delta U, mathematical form of first law of the thermodynamics, if there is work done on the system. On the other hand, if there is work done by the system, then the first law of thermodynamics in terms of change in entropy can be expressed as delta U is equal to Q minus W, where W is the work done by the system. So it is taken as negative, and it is equation number 2. Write down, where W equals to work done by the system. Now this video is completed. Graduation B.Sc Part 1 B.Sc Part 1 chemistry courses, B.Sc Part 1 chemistry honors, chemistry general and chemistry subsidiary courses के स्टूडेंट्स की सुविधा के लिए मैंने फिजिकल केमिस्ट्री का चैप्टर थर्मोडायनामिक्स और थर्मोकेमिस्ट्री के वीडियोज को भी अपलोड करने का डिसीजन लिया है। इसके अलावा क्लास 11 फिजिक्स के लिए भी यह वीडियो बहुत ही हेल्पफुल होगा, क्योंकि क्लास 11 के सिलेबस में भी थर्मोडायनामिक्स फर्स्ट बुक में थर्मोडायनामिक्स चैप्टर है, तो उसमें भी आज के वीडियो का टॉपिक्स क्लास 11 केमिस्ट्री के भी सिलेबस में इंक्लूडेड है। थैंक्स ऑल ऑफ यू फॉर वाचिंग माय यूट्यूब चैनल फिजिक्स क्वांटम क्लासेस।